When you deploy applications to Azure, your goal isn't just to get them running. You want them to stay running even during maintenance events or hardware failures. That's where availability sets become essential in your high availability strategy. Let's walk through what availability sets are, how they work, and why you should use them. An availability set is a logical grouping of related virtual machines. You use it to ensure that your VMs are deployed across different hardware resources in Azure. This grouping helps you prevent a single point of failure. If there's a physical hardware issue, or if the platform undergoes maintenance, only a subset of your VMs is affected, keeping your application available to users. When you are working with availability sets in Azure, your goal is to design virtual machine deployments that can withstand failures and planned updates. To do this effectively, you need to group VMs that perform the same function, like all web servers or all application servers, into a single availability set. Each VM in the set should run the same software stack, ensuring consistency and easier management. Azure automatically distributes these VM across multiple physical resources, different servers, racks, storage units, and network switches. That way, if a hardware issue occurs, only part of your availability set is affected, not your entire application. It's important to note that you can only assign a VM to an availability set during creation. If you ever need to change its availability set later, you'll have to delete and recreate the VM, so plan accordingly. You can build availability sets using a variety of tools, depending on your preference, such as the Azure portal ARM templates for automation, PowerShell or CLI scripting, or direct interaction via the REST API. To give your availability set high resilience, Azure uses two internal distribution mechanisms: fault domains and update domains. A fault domain represents a group of VMs that share the same physical infrastructure, like a rack, a power source, or network switches. If something fails in that domain, for example, a power outage or hardware fault, all VMs in that domain might be impacted. By placing your VMs across two or more fault domains, Azure ensures that your application doesn't go down entirely in the event of a physical failure. You maintain availability even during an outage in one fault zone. An update domain is a logical grouping of VMs that Azure updates together during platform maintenance. The best part? Only one update domain is rebooted at a time, allowing the rest of your application to remain online. By default, Azure provides 5 update domains, but you can configure up to 20 depending on your workload needs. Each VM is automatically assigned to a unique combination of a fault domain and an update domain, giving your deployment maximum protection. When you combine these principles, fault isolation through fault domains and rolling updates through update domains, you are building infrastructure that's not only reliable but also resilient by design. And that's exactly what great Azure architecture is all about. To get the most value from availability sets, you'll want to follow a few essential best practices that strengthen your deployment and minimize disruption. First, design for redundancy by using at least 2 virtual machines in every availability set. If you only use one VM, you won't benefit from the availability guarantees Azure offers. Redundancy ensures that if one instance goes down, another remains available to serve traffic. Next, separate your application tiers. Place your web tier, application tier, and database tier into different availability sets. That way, a failure in one tier won't impact the entire system, allowing the rest of your app to continue functioning as expected. Also, make sure you use load balancing. By combining availability sets with the Azure Load Balancer, You can evenly distribute incoming traffic across healthy virtual machines, improving fault tolerance and network performance. Finally, don't forget to use managed disks. Pairing your availability set VMs with Azure Managed Disks gives you reliable block level storage, which is more resilient and easier to manage than traditional storage options. While availability sets are great for protecting against infrastructure level failures like hardware crashes or host reboots, they don't shield your environment from application crashes, operating system issues, or software bugs. To cover those risks, you will need a broader strategy that includes regular backups, application monitoring, and failover and disaster recovery mechanisms at the app level. When you deploy two or more VMs in an availability set, Azure backs your deployment with a higher SLA, typically 99.95% uptime. That's your reward for designing with resilience in mind. It means fewer disruptions, better uptime, and greater confidence in your architecture. Picture this. You are deploying a 3-tier web application. Your web tier has 2 VM inside one availability set, while your SQL tier has 2 more VMs in a separate availability set. Each set is distributed across 2 fault domains, meaning your VMs are placed on different physical racks. Now imagine one rack fails. Because your tiers are isolated and spread out, only one VM in each tier is affected. The remaining VMs stay up, and your Azure Load Balancer reroutes traffic to healthy instances. Your app keeps running with minimal impact, exactly how high availability should work. By applying these strategies, you're not just deploying VMs, you're building a resilient, enterprise-grade cloud solution that can stand strong in the face of failure. So, what's your key takeaway? Availability sets are one of the simplest yet most powerful tools in your Azure toolkit to build resilient cloud solutions. They help ensure that your services survive hardware failures and planned maintenance without you lifting a finger at the time of failure. Plan your deployments with availability sets at the core, and you'll be designing for durability, performance, and peace of mind.